Let's take a look at this. Synthetic division uses a pattern here. It has two patterns that it incorporates. It incorporates a vertical pattern where we add down. The vertical pattern says add returns, add down. A diagonal pattern, see your diagonal, it actually goes like this. K times A. There's your product right in there. We're multiplying. This puts your product out there. Okay? Then we follow again. Add down. Then multiply. Then add down. Then multiply. Then add down. This side, this last piece right here, I always box it out. This is where your remainder goes. Because when you divide, do you always have it divide evenly? No. So remember back in the day when you guys were younger, you would do 59 divided by 7. 8 gave you 56. Remainder 3. When you were little, you said R3. And then the next step was 3 over 7, right? So we're going to keep that concept. We're going to keep that concept when we divide. We're just going to take whatever remainder and put it over the denominator. Now, this remainder stays. What's left here, notice what this says, is the coefficients of your quotient. The coefficient. To get back to another polynomial, we have to figure out which one do we start with and work our way through. And we're going to do that.
So, you know when it's into the vertical pattern, you add down?
The verticals, you add down.
Yeah, so where it says B, and then has the K8 underneath, how do you do that?
Because this, well, we're going to put numbers in here. But you would add this number to this number and get that one. Yeah, we're going to do that with numbers. It's going to look a whole lot nicer. It's going to look a whole lot better with numbers in there. So now.
But why is, like looking at number 1, why is it -3, but this is x plus 3?
Okay, good point. So if I take this side and I divide by x plus 3, this is a factor. We want to make this into your zeros. Okay? This is what we want to look at, the x minus c part, where your factor, your zeros come out. So we're going to technically take this and set this equal to 0. What we need to make sure is that that leading coefficient is 1. And in this case, is it 1? So we're good right now. So we'll get to that. Let's start real basic. So I subtract 3. This is my root, my zeros. Right? If I pull this up, if that's possibly a root, then I'll be able to see that. If it doesn't come out with a remainder, then I won't be able to see that. Okay, so let's take this and develop this. Now, watch what happens here. Let me see if I can move this up a little bit. It's taking all your coefficients out of here first. But you have to make sure that every exponent is accounted for. Do I have an x to the 4th? Do I have an x cubed? No. So that coefficient will be 0. I need a placeholder. Because isn't anything times 0, it's gone, right? Then I have a square, then I have a 1, and this guy is actually x to the 0, which is 1. So I never see the x. So pull out the coefficients. 1, 0, -10, -2, and 4. And I always check. Yes?
Where did the 0 come from?
The 0 came from, we needed to have somebody for x cubed. So since there's no x cubed, it must have been multiplied by 0. We need a space holder. Anything multiplied by 0 doesn't exist, right? So its coefficient must be 0. Because we're missing one. In between x to the 4th and x squared should have said x cubed, right? But if it's multiplied by 0, do we really need it? No, but in synthetic division, we need this space
You
holder.
have to show everything, right?
Yep,
Sure.
we have to have a space holder. Now, before you divide, you always check. My highest exponent is 4. 4, 3, 2, 1, 0. I got to start at my highest and go to 0. If I missed my x cubed, I wouldn't be going to 0. I would be like this. 1, negative 10, negative 2, 4. It would say x to the 4th, 3rd, 2nd, 1st. Whoops, my 0's missing because I forgot to put that space holder in. Every exponent needs to be accounted for. Now, that is this right here. They pulled out their coefficients. Everybody with me? I like this one because we can use your pattern right in this problem. Now, it's being divided by x plus 3. And we said the leading coefficient is 1. So this set to 0, x is equal to negative 3. There's my root right there. X plus 3 is a factor. X equals negative 3 is a root. Not unlike you did last week, right? Okay. Now, follow the arrows. Vertical patterns we add down. Diagonals we multiply. So first time through, bring this down. There's nothing to add to it, right? There's nothing next to it. So bring it down. Now watch. Here's your pattern. Negative 3 times 1 is what? So that goes right here. Negative 3. Now, add down. Negative 3. Now we're going to multiply again. Ready? Negative 3 times negative 3. Look where it goes. To the right here. 9. Add down. What do you get? Negative 1. Okay? Again, pattern. Negative 3 times negative 1. 3. It goes right here. To the right. What is negative 2 plus 3? 1. And the last one, negative 3 times 1 is what?
Oh,
Negative 3. Diagonally you multiply. Add down. 1. Put this guy up. This is your remainder. Now remember up there, it showed that those were your coefficients to your solution. So, we got to see what do we start this thing with. So remember when you were younger, you had a big division problem. You had something like 4, 9, 6 divided by 3. And they said, look at the front end. Can I put 3 into 2? Can I put 3 into 24? So it's probably an 8 up here. That's your front end. So let's look at your front end. What's x to the 4th over x? X to the 3rd. So this is going to be x to the 3rd, x squared, x1, x0. And we're going to attach them now with our coefficients. What is x to the 0? 1. And you don't have to write x to the 0. But the key is it goes from the highest down to 0. So, 1x cubed minus 3x squared minus x plus 1. And here's my remainder. Remember in the old days you put that remainder over your divisor? Plus 1 over x plus 3. That's my solution to this division. To this division problem. Now, you can check this. You could multiply this times this, and then add 1, and you will get back up to this one. Okay? Still not good?
Is that all you?
But anytime you do this, this is the pattern that you're following. Okay? So let's try another one. Yeah, I want you to write this. I want you to write this in. What's that? Yeah, no, I'm just going to work on the space right over here. Remember the one I gave you before? Then write it on the back of the page, anywhere that you can find space. Now, and 7x plus 6. Okay, now, can we factor this guy? No. So if I pull this up on my calculator, here's my equation, x squared minus 7x plus 6. How many roots do I expect to see? 3. So I see 3 roots, right? 1, 2, 3. I can't factor that as it is. But if I could divide one of those roots out, then I can see if what's remaining is factorable. This is where this is heading towards. So let's take a look at this. Pull the first one out. X is 1. See it? I don't want the rest. I just want one of them. What's the factor for this?
But you have to do this in order to divide it.
Because I'm going to pull out the rest of your roots. I'm going to show you what happens when there really are roots that keep coming out. So now, what's the factor for this? Step is equal to 0. What do I get? X minus 1. This is my factor, right? So I'm dividing this by x minus 1. With me so far? Okay. Now, I wanted it here so you could see what this is doing. This said pull out the coefficients. So I see an x cubed. Do I see an x squared? No. So what do I have to put in front of the x squared? 0. Good. I need a space holder. So now give me the coefficients you see. 1, 0. So let me test this. 3, 2, 1, 0. 3 is my highest. 3, 2, 1, 0. I'm good to go. Okay? Now we're going to divide by your 0 for this, which is 1. That's this guy out here. Now let's follow this dotted one here. We're following this procedure. Bring the first one down. 1. Then diagonal. Multiply. 1 times 1 is what? 1. See it diagonally? To the right. 1. Add down. 1. 1 times 1. 1. Bring it up. Negative 7 plus 1. 1 times negative 6. Add down. Oh, 0. My remainder is 0. That's a factor. Didn't I see this as a factor? I saw this as a factor. So, I want to see now if what's left, I'm actually able to factor this. So, I notice my front end says x cubed over x. What's my highest exponent have to start with?
Sorry, what do you mean when you said you saw the 0 as a factor?
Here's my 0 is a remainder, which means this was a factor of this equation.
Oh.
So now, I want to see what this solution is. These are the coefficients to my solution. So x cubed over x, what's my starting exponent going to be? X squared. So x squared plus 1x minus 6 is what I'm left with. Can I now factor this guy? Can this be factored? Into what? So, there's the rest of my zeros. And x equals 1 is one of them, isn't it? Now, this is why we're doing this. Watch. This original one, could you factor? No. But when we factored out, divided out the first 0 that we saw, were we left with something else that we could factor? Yes. So synthetic division is there to help us find a factor, if we can, when we graph it, divide it out, and then possibly be left with something we could factor. Agreed? Now, to keep going with your synthetic division, we have this example. Now, this example says, take this polynomial and divide it by 3x minus 2. The problem with this 3x minus 2 is that leading coefficient, the leading coefficient must be 1. In my denominator. It's not, it's 3. Remember when we did complete the square and your leading coefficient had to be 1? So we factored out the number, right? So we're going to take this and we're going to factor this out. So what can we factor out? I need this to be 1. 3. So divide everybody by 3. So I get x minus 2/3 equals 0. Now, I'm going to divide this by 3, but I want you to remember that we did this. So x is equal to 2/3. This is a root. Maybe. This may be a root. I need to test this. If I divide and I get a remainder of 0, I'm a root.
Why did you go through all of that instead of you just do 3x minus 2, subtract 2, and then divide by 3?
You're right, and that does give me this root, but it doesn't give me the fact that I had to get rid of that 3, because we're going to come back to this point. So we do get the root the same way. However, my last class I did it that way and I worked myself backwards, and I think I kind of confused them. So this time around we're going straight forward. We're saying that this has to be 1, so we factored out the 3 first. Okay? But it is the same as your 0, but you're going to lose that 3.
Has
Now,
to be 1 before we divide it, right?
it has to be 1. Okay. Now, does this guy have everybody? 3, 2, 1, 0?
Yes.
Okay, give me the coefficients.
6.
So 6, negative 16, 17.
Okay. And what's my root, possibly? My divisor? 2/3. Oh, now don't panic because it's a fraction. Because I wouldn't make you have fractions. I'll make them work out nicely. So watch. We bring down the 6. And what's our next step? To multiply. So I say 2/3 times 6. So therefore, that comes out. And what do I get? 2 times 2? 4. Ah, 4. I multiply. It goes here. 4. Not a problem with my fraction. So I add down. What do I get? Now notice that negative 12 is a multiple of 3. So therefore, when I multiply, shouldn't I get rid of my fraction? So 2/3 times negative 12, this will become negative 4. And what's 2 times negative 4? Negative 8. I multiply, I put it here. I add down. Yeah? 2/3 times negative 12 gives me negative 8. Now add down. What's 17 plus negative 8? 9. Oh, I noticed 9 is a multiple of 3. So 2/3 times 9 gives me what? 18 over 3 or 6. So I multiply and that goes here. Ah, 0. So this tells me that this is a root of my equation. Now let's see what's left. Okay, let's just see what's left. Front end. Just look at your x values. What is x cubed over x? X squared. So this is x squared, x1, x0. 6x squared minus 12x plus 9. Now, we said that would have 3 roots. This is a 0. This is factorable. Maybe not like what we would like to factor it. We could divide everything by 3, right, to factor it. We could do the a times c, and if we find we can't factor it, we could always use the quadratic, because maybe these are not rational roots. But today, all I want you to do is divide. Tomorrow we're going to continue the rest of this process with factoring the rest of it. And if we can't factor something, we just use the quadratic. But you knew that this had to have 3 roots. Whether they're real or not, we don't know yet. But we know there's one of them because this came out to be a remainder of 0. So we know 2/3 is one of them. So if we graphed that polynomial and we did a calc on 2/3, we would see that root, that y was 0. We would see that. And this ties in what we were doing last week. But the only thing we changed on you now was you were able to factor everything last week. This was not factorable as we look at it. Maybe we could group it. Still is not factorable if you group it. It was not factorable, so we have to find another way. So if we could divide out a root, we maybe could get it to where we could factor it. Okay? Now, what we have to do now is, remember we had this little asterisk here? Right? We have to come back to this. We said, remember, we have to come back to this. Because Melisande said, why can't I just set that equal to 0? I said, remember, we have to come back to the 3. Now, me, because I talk in between, because I'm writing and not paying attention, I sometimes forget. So when I do this, I always put an asterisk, or I put a circle around it. I do something to make me remember. If I divided this by 3, I have to divide this by 3.
Why?
Why? Because I will tell you why. If you checked, right? Remember you check, you can multiply them, they should come out to be what you originally started with.
Oh, yeah.
Front end, what's 3x times 6x squared? 18x cubed. Is that 18x cubed? No. So this is not going to work. I divided this by 3. I also have to divide that by 3. So let's divide everything out. 3 goes into 6 2 times. 3 goes into negative 12, negative 4. 3 goes into 3, 3.
I mean 9.
3 goes into 9, sorry. 3 goes into 9, 3 times. Now, front end. 3x times 2x squared is what? 6x to the third. Well, it's just a quick check. You know, like when you're checking your multiplication, you check what you divided against what you divided by, and it should be what you started with. So if we check this against this and multiply these, without multiplying the whole thing, shouldn't I at least get the first term, right? So that's a good way to
That's
see.
why you couldn't do 3x minus 2 equals 0.
Yes.
Because I did that, I got the same thing.
You do. You absolutely do. Your root is 2/3. And if you put this in your calculator, your root will be 2/3. But when we're dividing, you divided out a factor of 3. So at the end, you have to remember to divide out the same factor of 3 out of everything else, or it won't be even. If you divide one group to 3, you got to divide. It's like an equation, right? You divide one side by 3, you have to divide the other side by 3. So if you divide one factor by 3, you have to divide the other factor by 3. And that's why we said put an asterisk and make sure we remember to come back to this. We have to divide this out. And quick check shows you that this front end will never get back to that unless you did divide by 3. So remember, your leading coefficient has to be 1. Now, on tonight's homework, do you have any questions?